Today in the world, poverty has decreased like never before. Cities and urban areas are expanding at a breathtaking rate. The quantities of concrete used in construction are growing exponentially. With such acceleration, the completion of construction projects worldwide every week is equivalent to the entire urban area of Paris. In the last 3 years, China consumed an amount of cement that surpasses the total sum of cement consumed in the United States over a century. Despite this growth, we can observe a significant lag in innovation in the construction sector compared to other industries. In fact, we are still largely dependent on manual labor and archaic technologies. Often, we simply pour concrete into pre-made molds. You can see the internal structure of bone. Imagine if we wanted to replicate this efficient material-saving structure for our buildings. Until now, it would have been impossible. A system of slabs developed at the University of Zurich attempts to replicate this effect. The Institute of Architecture is researching how 3D printing technologies can be used to incorporate concrete where it is needed, leaving voids where concrete does not bear loads, as well as ensuring that heating, ventilation, and other utilities can be efficiently installed in pre-designed spaces. The slab elements are printed in sand baths, where adhesive is applied layer by layer on the surface of the spread sand, resulting in a product that does not require any casting forms or support because it floats in the sand. Later, the remaining sand can be reused again and again, significantly reducing waste in construction. This work by the Institute of Architecture is significant because it not only demonstrates the possibilities and advantages of 3D printing, but also shows how this technology can smoothly integrate into an existing industry, becoming a transitional step where revolutionary technologies lie on top of masonry walls. Construction sites look brutal. Human activity almost always destroys ecosystems and pollutes the environment. China, due to its rapid and sometimes uncontrolled growth, has faced numerous environmental catastrophes. The largest 3D printed project in the world currently underway in Shanghai aims to halt coastal erosion and compensate for the lost ecosystems by creating space for vegetation and pockets of water fauna to take refuge between flood cycles. Different-sized animals will find suitable habitats in these spaces. Different-sized animals will find suitable habitats in these spaces, providing water and coastal plants as shelter from intensive shipping along the rivers of Shanghai. This project is significant because due to its scale and the involvement of specialists in technology development, it will allow China to make progress in the field of 3D printing, reduce the cost of technology, and make it accessible to the mass consumer. This is an essential condition for achieving a breakthrough. One of the most famous and elegant examples of 3D technology development is the bridge under construction at the University of Amsterdam. Enthusiastic researchers came up with the idea that robots, printers, can take on the construction of a bridge on opposite sides of a canal and meet in the middle without the need for additional supports in the water. The idea arose when they realized that welding robots widely used in mass machine production are excellent printers, autonomous, mobile, and quickly replaceable. By employing programming and parametric design, the creators enlisted robots to perform precise movements and actions and conduct material tests. The result of these studies will not only be a bridge, but also an entire library of algorithms, calculations, and experiments that will contribute to further technology development, enabling the generation and construction of different geometries entirely automatically. Working with printing robots, we are not limited by size or geometry, which is usually a constraint in immobile printers, as seen in the sand bath. Theoretically, we can print products of infinite size. This means that now we can produce millions of different products with a single machine. we can see the result of how this bridge looks. After numerous attempts spanning several years, this masterpiece has finally gained a physical form. The bridge stretches over a channel with a width of over 12 meters and weighs nearly 4 tons. 4 robots took 6 months to fabricate this bridge, using a kilometer of stainless steel wire for welding. The bridge fits organically into Amsterdam's Old Town, despite being a very modern creation. The product meets all safety requirements and is approved for public use. Prior to the construction of the bridge, computer simulations were carried out to ensure its durability and safety, which matched the specifications of the actual structure. The certification of technology, obtaining construction permits, and obtaining operational permits indicate that the achieved discoveries are safe and worthy of investors' attention. This means that in the future, we can expect even more advanced robots that will relieve us from physical labor, saving our materials and time without generating any waste during the production process. This is a significant breakthrough in the field of 3D technology, but such successful projects are rapidly being implemented worldwide. In China, very recently, the world's largest bridge made of printed concrete was opened to the public. This event marks another milestone in bringing us closer to the 3D manufacturing revolution. The project was carried out by a team at Tsinghua University School of Architecture in Shanghai. The bridge was constructed by 2 robots in 450 hours. Calculations reveal that this bridge saved approximately 33 of resources, largely due to the elimination of physical labor, material quantities, supports, and machinery required in traditional construction methods. Embedding sensors into the concrete structure of the bridge will allow real-time monitoring of vibrations, stresses, and loads. The data obtained will contribute to a better understanding of the practical application of this technology and ways to improve printing components, concrete, and structural properties. By employing computer calculations and simulations, we will soon be able to print bridges that surpass the previously constructed ones in all aspects. They will be cheaper, safer, more durable, and faster to build. This project has already attracted the attention of private companies in its early stages. Thus, successful collaboration results and business investments in science lead us to expect impressive projects in the very near future. In 3D printing for construction, we mainly use familiar materials. Essentially, it involves robots replacing our physical force in construction, where we use time-tested materials. Robots can deposit materials horizontally, a method that resembles injecting a concrete composite from a needle, which is most familiar to us as it has been used and demonstrated for many years. However, robots can also apply materials vertically, as demonstrated by this rendering machine. In fact, robots do not have to operate in a 2-dimensional space. More advanced robots equipped with sensors can perform automated bricklaying tasks. Essentially, it is a 3-dimensional printing with bricks. Robots that intricately tie reinforcement meshes according to program-to-program geometry also use a common and inexpensive material available anywhere in the world. This is an example of how, once we acquire a robot, we can employ them without additional expenses, without worrying about the incompatibility of traditional construction methods. The robot again imitates human technique, but performs everything faster, more efficiently, and eliminates risks to human health. The good news is that this robot is commercially available and can be purchased by any construction company. Just as we can recall the early computers or phones in the market, we can only imagine how imperfect this technology is. But at the same time, it signifies a leap forward in the 3D printing revolution. Metal printing, welding, melting, or tying reinforcement meshes are popular research areas in architecture institutes worldwide. Another popular field is the search for alternative composite materials suitable for printing, which could also be environmentally friendly, affordable, durable, and convenient to use. Until now, many works performed with 3D printing technology have been experimental, exploring their limits and possibilities. As a result, we can observe examples of small-scale architecture in major cities around the world, where numerous enthusiasts from the worlds of science and business invest their time in this innovation. The rapid development of artificial intelligence and robotics will open the gates to a new era for humanity, transforming all areas of our lives. From smart homes to AI-driven cars or planes, the possibilities for applying artificial intelligence and robotics discoveries are practically limitless. Although the construction industry has been stagnant for centuries, it will not escape this progress. These are extremely exciting times for architects. Many architects are at the forefront, along with other pioneers, solving entrenched problems using 3D printing technologies. There is a difference between a robot and a machine. We can program a robot and assign it complex tasks. But the most important aspect is that a robot can operate autonomously. The most common form of robot today is the mechanical arm. These robots have been working in factories for many years, performing dangerous and monotonous tasks instead of humans. However, as we have seen, these robots are now moving to construction sites. These robots will have a tremendous impact on the construction industry, eliminating accidents and being several times more productive. The world's first commercially available robot that performs masonry work can build a house in just 2 days. In America, a robot that ties reinforcement is working on bridge construction. In Zurich, robots working with their mechanical hands precisely create surfaces in complex geometries. These robots impress architects with their ability to handle intricate shapes and structures without straight lines. Although they can also pick up a regular piece of wood and build rectangular boxes just like humans. A significant breakthrough in 3D printing technology occurred with this 2-story building in Germany. It is the world's first 3D printed residential house, fully certified according to national construction codes and regulations. The impact of this event on the construction industry and the future homes will be tremendous. The technology used for small-scale projects has long promised to solve resource-saving problems in construction. It is believed that 3D technology is also the answer to many global challenges, such as poverty reduction and climate change. Although such projects are being carried out worldwide, from China, Canada, and the Netherlands to Dubai, where the goal is to build a quarter of all houses using printing technology by 2030, this technology is still in its early stages. However, this 162 house printed in Germany has pushed us closer to the revolution. Essentially, it is the first 3D printed building certified according to rational building regulations, demolishing the main barrier for such structures and paving the way for larger, more complex, and superior projects. The team that implemented this project is already preparing for the construction of a new multi-story building. Their goal was to understand the competitive environment and prepare for the future, quickly realizing that being pioneers in 3D technology would give them a competitive advantage. Perry took on the development of this project. Their aim is to become what Tesla is to the world of electric vehicles in the construction industry. Only 2 people are needed to assemble this house printer on the construction site. It is prepared within 2 days and can start working according to the launch program. Then the printer operates completely autonomously, printing at a speed of up to 1 meter per second until it completes all the tasks specified in the program. Although the architecture of such a house may currently seem quite boxy to us, we must understand that this early-stage prototype will differ from future homes in the same way a smartphone differs from the Nokia bricks we used not too long ago, proudly holding them as trophies of progress. Finally, I want to introduce you, or perhaps remind you of the latest project today, which is the architect, Michael Hansmeyer's experiments with parametric design and 3D printing. His work Subdivided Columns seen in London back in 2010 amazed me and has never left my mind when I think about the future of architecture. Recently, the exhibition Digital Grotesque was traveling around the world, including Shanghai, London, Paris, or Berlin, where these enchanting creations were showcased. I will leave you with these images for a couple of minutes. 3D technology has been making its way towards mass adoption for a long time. But why hasn't it become popular until now? 3D print influences the entire construction process, the work on the site, the composition of walls, and even the design process, permitting and documentation areas. All the thresholds that need to be overcome for this technology to be used today can deter people. However, we often fail to realize that it is a complex process, and every successfully printed house that the media enthusiastically describes has initially encountered numerous failures. In this video, we see one such failure, which often doesn't make it into the media. Incorrect printing speed, material composition, product geometry, even air temperature or humidity can result in a failed attempt. That's why we have been initially seeing simple printed objects such as flower pots and outdoor furniture. But today, the pace and competitive environment are growing exponentially. I wish all of us to experience and be part of this revolution.